Stepping through Func plus 94, the last store, this should have been the largest stack diagram to date. And it breaks up roughly like, well, not roughly, it breaks up exactly like this is main's frame and this is Func's frame. So you will see that the arguments, the two arguments beyond the ones that we could store in argument registers, got stored onto the stack before main called into Func. So those were at the stack pointer address at the time that it was about to call in. And that is exactly what we should see based on the calling convention ABI information that we saw earlier. It said that the first argument should be placed where the stack pointer is with subsequent arguments at higher addresses. So the overall takeaway that we have from this, we see typical things like saved return addresses, saved frame pointers, alignment, the single Z variable, but since there's only a single 8-byte variable, there's an extra 8 bytes for alignment to hex 10 boundary. But what was interesting and a little bit weird about this is the fact that each of those argument registers is ultimately saved off to the stack. Now, we could see that GCC really likes to use things like argument 4 and 5 as its temporary registers. So in some sense, if it wants to smash the argument 4 and 5, it makes sense to store off a copy of it, but that doesn't seem strictly necessary. It could have used things like temporary registers, T0 through T6. So once again, we might infer that this comes down to the fact that we're looking at unoptimized code. So again, the arguments, this was the area where we saw all these load immediate instructions storing the argument 0, argument 1, argument 2 for each of our arguments. And obviously I selected the values so that it was very clear that argument 0 was 0, argument 1 was 11, and so forth. So you could understand exactly that they went in this order, not perhaps the opposite order. Then we had those stores to the stack in main still of the extra arguments. Once we got into Func, we saw all of this storing of those arguments immediately off to the stack. And we saw that when it actually operated on values, for instance, this loading from frame pointer minus 40, well, that's where it stored the argument 0, frame pointer minus 40. So loading it up, it really likes to use these A4 and A5 as its temporary things, just reuse them over and over again. And that's what we see here. Now I do smell deception, so I do want to rewrite reality and see what it holds. And indeed, we have a compressed lie is being used here. These are not just normal lies, these are compressed lies. So we said lie is a lie, it's actually add I, and some of those lies turned into add I's, but other ones turned into compressed lie. And what's the difference? Why would a compiler choose to use 3 compressed lies and add I's for everything else? Well, we'll see in a second. And then we also picked up a compressed sub so soon after we just learned about sub. So compressed sub, compressed subtract, register to register. This is a 2-register form, just like the compressed add we learned about before, and it is using those narrower set of possible registers, the RD prime and the RS2 prime. So it does RD prime as its source 1 minus RS2 prime as its source 2 and stores the result back into RD prime. So yes, unlike the RV32i, which doesn't have 2-register forms, compressed is again just fine having the 2-register form with an implicit use of the destination as a source as well. But one little thing that threw me with the C sub when I was reading it is that C add actually was encoded in a way that it could use the full possible 32 registers for a destination, for instance, but C sub is not. C sub can only use these prime registers. That is the definition here, so the X8 through X15. So again, that's what I said before of if you're reading it, you're just reading, subtract some register, some register. You need to know that it's this minus that back into that. And you don't really care about, is it some subset? Reading is easy, but if you're writing, you have to actually read the fun manual to figure out what restrictions apply, if any. And so here was our reminder about the load immediate instruction from before, but of course the key thing you need to remember is that the lie is a lie. But li took a 12-bit immediate and stored it into a destination register. In contrast, the compressed li takes a 6-bit immediate. It's still sign extended, but it is then stored into the register. So that should give you a quick sense of why in the assembly we saw only 3 compressed LIs for the 3 smaller values, and then once we went up to a larger value, specifically 33, then we could no longer use a compressed LI because 33 cannot be encoded in a signed 6-bit value. So at that point, the compiler went back up to the add i's for LIs. So with the compressed LI, just as an FYI, there is a destination not allowed to be X0 constraint on this. So new assembly instructions we picked up, sub, and sub pops in right here. We also picked up a compressed sub and the new compressed LI.